All right, in our last lesson, we introduced the idea of logarithms, right? Logarithms are the opposite of exponential functions. And in that lesson, we talked about how the rules of exponents are very closely related to the rules of logarithms. So what we're going to deal with today are a little bit more of those rules and how they apply when we have more than one logarithm. All right, so the first one here is the logarithm of a product. And the idea is that when I have the logarithm of a product, I can split them into a sum of two different logs. Now, the rule that this mirrors is the rule that b to the m times b to the n equals b to the m plus n. Now, because logs are exponents, the same rule applies here. So if I go over here, I can do this a few different ways. The first thing I can do is I can combine these. I can write this as the log base 2 of 32 times 4. And now that is 128. So that is 2 to what power is 128? 2 to the, let's start low, 4 is 16, 5 is 32, 6 is 64. So this here asks me 2 to what power is 128? Well, it's 7. Let's make sure we believe that rule. I can also write this over here. Log base 2 of 32 is 5, and the log base 2 of 4 is 2, and again, we get 7. We've checked our work. The next rule is very closely related. It's the logarithm of a quotient. Now, when I have the logarithm of a quotient, I can rewrite that as two separate logs as a difference. Remember, when we divide terms with common bases, we subtract their exponents, or we know that, where's my pen? B to the m over b to the n equals b to the m minus n. So this is the equivalent rule in logarithms. If I look over at my example here, we're going to solve this both ways. The first thing I'm going to do is combine this. I can write this as the log base 3 of 729, that's a 29 over 9. Well, that's the same as the log base 3 of 81, which I can evaluate as 4. I can do this another way. I can just evaluate each of these individually. 3 to the 6th power is 729, so this here is just 6. 3 to the 2nd power is 9, so I can evaluate this as 6 minus 2, or 4. Again, we've checked to see that our rule works. Finally, we have the logarithm of a power. When we have the logarithm of a power, when we had the exponent of a power, we wrote it like this, right? B to the m to the n was the same as b to the n times n. Well, this is the same thing here. So what happens in this rule is if I have an exponent as part of my logarithm, it can travel to the front and become a multiplier, right? An exponent multiplied here, an exponent multiplies here. So what does that look like if I look at the couple examples here? Now they want me to condense this logarithm to simplify. So on this problem, what I need to do is recognize where that multiplier is. In this case, that 2 is out front. If I want to condense this, that's really telling me that I can move that that 2 into an exponent. So I can rewrite this as the log base 4 of 8 squared. Well, I know 8 squared is 64, so this is really the log base 4 of 64, and all of a sudden the numbers are a little bit more friendly to work with. 4 to the 3rd power is 64, so that'll be my answer. On the next part here, we want to use the power property to simplify. Well, I don't know what 81 squared is. It's not something I know walking around, But what I can do is I can take this 2 here and move it out front. So I can write this as 2 times the log base 3 of 81. Now the log base 3 of 81, hopefully you recognize that 81 is 3 to the 4th power. So this whole term here turns into 2 times 4, which is 8. Our last new rule we're going to deal with here is our change of base formula. Now, what you're going to find is that the numbers we use aren't always super compatible. There will be times where our base and our logarithm number don't really work well together. This is a way to help use our calculator to get more decimal answers. So if I look at this example here, I have the log base 5 of 23. That asks me 5 to what power is 23, and it's not exactly an integer number. It's a little bit less than 2. So what I can do is grab my calculator and use that change of base formula. So what you need to remember is that I'm going to have a log in the numerator and a log in the denominator. The easiest way to remember this is that the base goes into the bottom of your fraction, and the other number goes into the top. So I can write log base 5 of 23 as the log of 23 divided by the log of 5. And this you can do right on your calculator. On the left-hand side of your TI-84 calculators, there's a log button. That is the log base 10 button. That's the easiest thing we can use. We can plug in the log of 23 divided by the log of 5, and I got 1.95 as my answer. Always good to go back and make sure that makes sense. In this case, I said at the beginning, it makes sense that log base 5 of 23 should be a little bit less than 2, and 1.95 fits the bill. All right, let's look at the type of problems that involve condensing and simplifying logs. So this is a specific type of problem that can be, it's a little bit more confusing looking than it actually is. So they tell us some approximate values. They tell us that log of base 10 of 2 is 0.301 and log base 10 of 3 is 0.477. Really what they want me to do is rewrite these examples using that information. So I don't know the log base 10 of 6, but I know that it's the same as the log base 10 of 3 times 2. And then using my first rule from above, I can write this as the log of 3 plus the log of 2. Well, I know that that's going to be 0.301 plus 0.477. And when I add those together, I get 0.778. All right, so I want to evaluate what I can when I can. Number 2 is here in the bottom corner. I see I have log base 3 of 2. Again, these don't really work well together, so I want to think about which formula I can use to rewrite this. I'm going to want to go ahead and use the change of base formula. What that's going to have me do is write this as the log of 2 divided by the log of 3. I know this section says not to use a calculator. It's going to be difficult if we want to get a simpler answer. So after we plug this in, we should get 0.63. If we move up to number 3, another example here, I want to simplify what I can. Now I know the log base 10 of 100 is just regular old 2 because 10 to the second power is 100. And I know the log base 10 of 3 is 0.477. That's what the problem told me. Now I just need to evaluate for a final answer of 1.523. Number 4 here, you may be a little thrown off because we have 8s and 9s. Well, I know that 8 is a power of 2 and 9 is a power of 3. So I can write this as the log of 2 cubed plus the log of 3 squared, which I can rewrite using my power rules as 3 times the log of 2 plus 2 times the log of 3. Why did we do that? Well, we know something about log base 10 of 2 and log base 10 of 3. We can write this as 3 times 0.301 plus 2 times 0.477. And once we simplify that, we should get 1.857. All right, there's a few more practice problems on the back, and I'm going to walk through those now. Looking at example number 2, I have the log base 2 of 32 minus the log base 2 of 4. Now I could do this one of two ways. I could simplify each individually. Usually that's my go-to move, or I can combine them into a single log and evaluate. Well, in this case, I have 2 to the 32. Well, I know that's regular old 5. And then 2 to the second power is 2. So this is really asking me what's 5 minus 2, and hopefully we know that's 3. Don't be nervous, we have some fractions here, but we are adding with a common base. So let's combine these first. So if I'm adding, I know that I can multiply 27 and 1/9 together. So once I do that, I get the log with a base of 1/3, and it ends up being 27 over 9, which turns into regular old 3. So I ask myself, 1/3 to what power gets me 3? Well, that's going to be -1. Let's scroll over to the bottom here. Sorry about that. And again, these are numbers that, as I look at them, kind of jump off the page at me. They're going to be easy to work together. I know that 7 squared is 49, so I know this is 2. I know that 7 to the first power is 7, so it's really going to be -1. My final answer here will be 1. And finally, I have this problem here. Log base 2 of 1/2 to the 5th power. Rather than multiplying this to the 5th power, I'm going to go ahead and take this 5 and move it out front. So I'm going to have 5 times the log base 2 of 1/2. So now I just need to figure out 2 to what power is 1/2. I know that negative exponents create fractions, so this is going to be 5 times -1, which is -5. The last two problems we have here are change of base expressions. I'll write these out and then let you guys finish them up. I know that when I change the base, I know that I have to change the base because 6 and 39 are not going to work well together. So what I'm going to do is take my calculator and take the log of 39 divided by the log of 6, and when I evaluate that, I get 2.04. Let's scroll over to the last problem here. Log base 3 of 95. Again, these numbers aren't going to work well together, so let's change the base. Log of 95 over log of 3. Use our calculator, and we find that our answer should be 4.15. And we're done.